Good morning, everybody. Sorry for the delay, but now able to get underway and start to introduce a very new, exciting family of microcontrollers, which will be announced shortly at the end of the month. So, SAM D20 is Atmel's new family of Cortex-M0 Plus based microcontrollers. Now, this initial presentation, which I will do now, is about positioning this new family and starting to explain to you how this will fit into the existing offering of Atmel today, and how our approach to this particular market space is a little bit different to some of the competitors that we have. First and foremost, some of our competitors have entered this space not necessarily with the right tool for the job. They've come from a position of Cortex-M3 and M4 products, high-end 32-bit processors, and basically just used these advanced peripherals with the new M0 or M0 Plus core, which is not necessarily a good fit for traditional 8 and 16-bit applications. And that's what you're seeing in the picture here, using a sledgehammer to crack a nut. Whereas Atmel has come from a very strong position in the 8 and 16-bit market space. And we have a broad portfolio of innovative peripherals, most of which have been designed from the ground up for this product. We have design teams which have experience in Xmega and with the Xmega D and E family. And you'll see as we start introducing the peripherals that we have a very similar features coming through in the SAM D20 family that we have in some of the Xmega D and E families. So Cortex-M0, in this family, we start seeing a number of different features and innovations coming to this family from a range of backgrounds. Firstly, from the Mega AVR. I think we were well known for ease of use in the 8-bit marketplace, and this helped very rapidly grow our market share in 8-bit. And also, the very strong tools offering that we have there. Atmel Studio, and now moving to Atmel Studio 6, and the support we have there for all the ARM products, bringing the AVR ease of use to the ARM marketplace. From Xmega, we have some of the innovative peripherals like the event system, the analog performance, the 12-bit analog performance that you typically get with the Xmega, some of the advanced timer counters, and when we released the SAM D21 family, the USB from internal RC. So ability to run very, very accurately from an internal RC oscillator. And on the SAM D20, that will come in the form of very accurate UART communications from an internal RC oscillator. From UC3, the family there, the peripheral touch controller, much improved now on the SAM D20, and sleepwalking, the ability of a peripheral to, in the deepest sleep mode, for instance, an ADC on a RTC timer overflow, request a clock so that it can complete a conversion, and then evaluate its own result to see whether it's above or below a certain threshold. So that's all about sleepwalking, and that kind of innovative way of keeping the microprocessor asleep for longer and saving power is coming quite strongly from the UC3 side. Also, the software framework initially made for the UC3s to enable customers to get into a new architecture more easily and more quickly without having to understand the peripheral level access of the part to such a degree. And then finally, the M0 Plus core. The M0 core from ARM was more an attempt to strip down the M3 and M4 cores, but it was not necessarily a perfect fit with the 8-bit market space. And some of the things like single cycle I/O access, where you're able to toggle an I/O on a single CPU cycle. These kind of operations are very important and get done very often in an 8-bit application. And so this core, the M0 Plus core, is a much better fit with 8-bit applications. So all of that comes together in the form of the SAM D20, the new general purpose microcontroller from Atmel. So to introduce at a high level, yeah. Okay, sorry about that. So to introduce at a high level the basic product offering, it's a 48 megahertz processor operating from a plus or minus 2% internal RC oscillator. The voltage range 1.62 to 3.63, that might seem familiar. It's the same voltage range that the Xmega operates at. And also it is 1.8 to 3.3 plus or minus 10%. So it enables you to run at 1.8 volts, but not necessarily have to have the most stable, expensive power supply. The flash range is from 16 to 256 kilobytes, and initially will be released in 32, 48, and 64-pin versions. Some of the key differentiating features of the SAM D20 from Atmel are the event system, both synchronous and asynchronous, SERCOM, or the serial communication module, which is configurable as I2C, SPI, and UART. And not only do we have now a single peripheral now, which is configurable in these different ways, but you also have I/O pin multiplexing, where you can have a given pin function on more than one pins. And so this adds a huge amount of flexibility to this as a platform microcontroller. Capacitive touch hardware engine. So we'll talk a little bit about the capacitive touch performance of this processor, and so far it looks pretty exciting. The ADC, 12-bit, 350 kilosamples per second. After further characterization, it's being increased from 300 kilosamples per second, and it also has a gain stage. And in addition, we have a DAC, 10-bit. Low power. Low power is something which should be synonymous with the name Atmel. It's a very, very strong emphasis behind any R&D that we're doing. And there's a constant strive with all the development teams in the silicon designers to constantly reduce the power of the microcontrollers. So the Pico Power technology from Atmel AVR products has been something which has been developed for many years. And now also we're leveraging off the fact that we have also released ARM-based Pico Power microcontrollers in the form of the SAM 4L. So the low power on the Atmel's SAM D20 series is in the region of about 150 microamps per megahertz, running full core mark, and we will put that in context against some of our competitors in the next few slides. Power down mode is in the region of 2 microamps, and that includes the RTC running with full RAM retention. Ultra-low power oscillators are a big part of the strategy of reducing the overall power consumption and the sleepwalking of the peripherals that I mentioned previously. Now, some of the exciting things as well is the wake up from very low power sleep modes on a pin change interrupt, on SPI data reception, I2C address match, or a UART start condition. Now, many of these, a wake up on an I2C address match may be a reasonably standard feature, but the fact that we now have a wake on SPI data reception in UART start condition is part of the flexibility that we're getting from the SERCOM module, and that some features which are not necessarily standard on some in one form of communication protocol are helping with others. In terms of the power consumption, we now look and we see how Atmel compares to some of the competitors. So Freescale has advertised some power consumption numbers of under 100 microamps. But that is typically achieved by running a cached program where there's no accesses to flash, and so the flash is not consuming any power. But if you're running a full core mark actively, then we are achieving very, very similar power numbers to them. But the lowest overall power consumption numbers are actually from the SAM 4L, which, as you can see, is more in the region of 106 microamps. The static power consumption. Now, the aim of this slide here is to show that even though we're making great strides in reducing the power consumption of 32-bit processors, that actually, in this 8-bit market space, the 8-bit processors are unbeatable. And the Mega AVR and Xmega stack up very, very well in applications where you need a very low static power consumption. Applications which need to wake up very regularly and have the full RAM retention and carry on where they left off. The peripheral event system. This is a mechanism to ensure that there is, you don't have to wake the CPU up on an interrupt, for instance. So CPU independent, 8 independent channels, and now both synchronous and asynchronous. So some of you may have heard about the Xmega E and the innovation that has brought in the form of the asynchronous event system, and we see that here as well on the SAM D20. And the importance of being able to process asynchronous events is that you do not need a peripheral clock running, and so often the processor can be in a much, much lower form of sleep mode but still process events. So safe fault protection and 100% predictable reaction time. Because now with the asynchronous events, it's more a case of a direct hardware wiring of a signal from event generator to the peripheral which reacts to an event. So this had advantage in the form of accurate timing, efficiently offloading the CPU, and reduced power consumption. Coming back to the serial communication module. Now this is configurable as I²C. In fast mode, as opposed to the standard mode of 100 kilohertz, we're able to operate up to 400 kilohertz, and possibly on the SAM D20 we might see the ultra mode of 1 megahertz. SM bus is a specific form of I²C communication, often used to talk to lithium-ion battery packs and the like, and we support that protocol. SPI up to 24 megabits per second, as with the UART, and we will see that the SPI and UART can be clocked up to half the system clock speed. Recalling that the CPU runs at a frequency of 48 megahertz, we can see where this 24 megabits per second comes from. Double buffered reception. This is part of the features which enable us to wake up from the deepest sleep modes without missing any data received on the SPI or the UART. Also, we have eye-open multiplexing, which means that we have a peripheral which is configurable in each of these different ways. But in addition, each of the signals can be routed to a couple of different eye-opens. So what this creates is a very flexible platform which generally makes the job of routing your PCB quite simple. It's connected to the event system and also reconfigurable from software. So the customer does have the opportunity, if they need, to have an SPI and reconfigure it on the fly to work as a UART. Or perhaps an SPI master and then configure it to be a slave as well. Wake up from all power modes on an I²C address match, SPI data reception, and a UART start detection. So the peripheral touch controller, we are expecting the full support in terms of the QTouch library to be available for the for the peripheral touch controller closer to the end of the year. And this supports buttons, sliders, wheels, and proximity. Proximity is all about detecting very, very low levels of capacitance and the changes in these low levels of capacitance, often, orders of magnitude lower than with a proper touch. And the real challenge is with these low levels of capacitive touch to actually pick up accurately the changes, but also eliminate all the noise in the system, which can be quite considerable. So proximity is implemented not as a feature in itself, but as a result of having a very, very high quality touch controller in a number of different ways. So many of the other features here, such as the superb sensitivity and noise tolerance, actually enable features like proximity. So it supports mutual and self-capacitive touch. These are loosely associated with QTouch and QMatrix, respectively. And we are moving towards these terms because they are more standard terms in the industry in terms of the different touch technologies. However, it is quite significant that we have both available on the same peripheral touch controller. And also, we have the ability of switching between one and the other. So the system is able to check whether it gets better touch readings using mutual or self-capacitance. And in different situations, one might be better than the other. Self-calibrating and tuning is also about the fact that different sizes of touch pads and the different delays associated with charging the capacitors associated with different size of touch pads is taken care of automatically. Also, there are no external components needed. This is also one of the key reasons why we can do both mutual and self-capacitive touch, because typically the external circuits of these two different technologies would have been a little bit different. We have the ability to wake up from power down or touch detection. And finally, the number of channel counts available is 16 by 16 or 256, 12 by 12, 144, and 6 by 8 or 48 touch pins or touch pads, which are available for us on this controller. The 32, 48, and 64 pin versions of this family have been laid out very consciously to ensure that there's easy migration between different pin count versions of the processors. So here on this diagrams, you can see the green parts as analog pins, and you'll see them in very similar locations on all three of these families. Similarly, the power and ground are on very similar positions, and it's almost possible to lay out a board for a prototyping type board for more than one package size, just with similar packages smaller packages placed in the center. Might be one or two small changes needed, but almost the same. So the first packages available are those 32-pin TQFP and QFN. So it's 32, 48, and 64-pin TQFP and QFN, the smallest being the 5 by 5 millimeter 32-pin QFN. With the SAM D20, we also introduce a new naming convention for many of the Atmel parts. So instead of calling this a SAM 0 Plus, which would have followed the naming convention of many of the other parts, we've instead adopted a naming convention more closely associated with the market segment that we are targeting this processor at. So SAM D is, the D indicates that it's a general purpose MCU. And 20 will be the product series. In this case, Cortex-M0 Plus CPU with a basic feature set. So the SAM D21 coming later on might have some advanced features like USB and more advanced timer counters, etc. And so that would have a different product series name. E represents a pin count, in this case 32 pins, and G would be 48 and J 64. 14 represents a memory density, in this case 16 kilobytes. So what you just have to remember is 14 is 16 kilobytes, and then 15 doubles, 15, 16, 17, etc. doubles the memory density at each point, up to 18, which is 256 kilobytes. A is a particular device version. So for instance, we would have had a Mega 168P, and then when we did a die shrink, we did some revisions, a metal layer change to that. We released the A versions of those parts, the Mega 168PA, for instance. Now, here we have introduced a major device revision in the part number already, so that the number of letters and numbers in the part number stay the same. And so if there are any major silicon revisions in the future, that would change the number, the letter there. M is the package type, in this case QFN. U is a plating material, in this case -40 to 85 matte tin plating is what U represents, and then T is tape and reel. So that's about the package carrier. So the initial family and what they all contain. So you'll see six 16-bit timer counters in the E family. G as well has 6, and J is 8. 4 SERCOM modules, 6 and 6 respectively in the different families. And you'll notice quite a high ratio of GPIOs to pin count. 25 GPIOs for a 32-pin device is quite high, and up to Atmel standards there. So all of these have as standard, most of the peripherals that I talked about here, the 8-channel event system, SERCOM support, and a 32-bit RTC with calendar mode. So where is this part positioned in Atmel's different portfolio of LEDs, of MCUs? So here you can see that we have a general purpose MCU segment, and then an ultra low power MCU segment. So the ultra low power segment, the Pico Power AVRs, are still the best power consuming MCUs that we have, and those will also include X-Mega AVR, which is also considered an AVR family. Then the SAM 4L, which has between 128 and 512 kilobytes of flash. In the bottom left-hand corner here in the general purpose MCU, we have Tiny AVR, and then followed by X-Mega D and E families. The positioning of the SAM...
It's really hard to read the slide.
Yeah.
Because of the surface of the wall.
Yeah.
I'm not too sure what I can do about that too much. Oh, that one? Do you think it would make a difference? Let's have a look. No. Any better? No. This one you need?
The problem is the projector is really, really poor. I can tell you one thing, it looks a lot better today than it did yesterday.
Yeah, I think it's just because this is a white slide, or is all of them that bad?
It's hard to read. It can be.
I think you just need to highlight where the different parts
Yeah, okay, so yeah, it's just the white writing on the white wall. So this is Tiny AVR here. This is X-Mega D and E. And here we have Pico Power AVR. And so the positioning of the SAM D will be more or less in this space here. So you will still offer the Tiny AVR for the low-end, low-pin count, general purpose MCU. The SAM D20 will fit into the space which the X-Mega D and E families occupied. And so it will be alongside and parallel to those Xmega families, and continue to promote the Xmega families where the customer would prefer the Xmega technology and would prefer the ultra-low static power consumption, etc. But the general purpose SAMD will take that positioning. So the device schedule from here and here being mid-April 2013. So we have public announcement of the M0 Plus in the earnings call at the end of the month on April 30th. Preliminary data sheet will be available in June, and samples of public release in August. Release to production in Q4 this year, and also the full software and firmware support for the touch peripheral controller, peripheral touch controller in Q4. So the touch is there, but it's not properly supported yet in terms of the firmware and software support, but that will come closer to the end of the year. In terms of tools, how will this part be supported? Well, we'll have C, C++ compilers in the form of GCC, which will be incorporated into the Studio 6 by default. Then we will have IR and CAL available as extensions through the extension gallery, which you can plug into Studio 6, and obviously supported through their own environments as well. Debuggers and programmers will have the AVR1, SAM ICE, and JTAG ICE 3. For development kits or programmers, we'll use the SDK 600 and also the SAM D20 Xplained Pro, which we'll also be using today in the hands-on. The Xplained Pro is an evaluation platform, a generic one where you can plug in a number of different wings to a the MCU board. And what's exciting about this platform is also the built-in programmer and debugger, which allows you to not only program the onboard SAM D20 target, but also an external target. So programming and debugging both internal, well, the onboard and offboard targets. Connectors for expansion wings, in this case shown here, the IO Xplained Pro, which we will use today, the OLED Xplained Pro, and the Proto Xplained Pro, which is this breadboard one here where you can prototype. So the Atmel Studio 6, so standard support there, and which now supports all Atmel AVR and SAM devices and is free of charge. Intelligent code editor, so as you start typing, the code in your project is referenced and it auto-completes as you start typing. Seamless connection to all in-system debuggers, and a cycle-accurate chip and peripheral simulator. The Atmel software framework with Project Wizard, and I think you'll see it's 4,500 projects as you load up the studio today. The version, new projects being added every month. Peripheral drivers, hardware abstraction, and communication stacks. We'll give the overview just now. And the ASF Explorer, the way to be able to add and manage ASF components and trace driver dependencies. You're able to also expand and extend Studio through the Atmel Gallery or online app store, and also the Atmel Spaces, now forming a cloud-based collaborative development environment for many customers to work on. So the way that you can have a look at the software framework and the positioning and what we're trying to achieve with this is that Atmel takes care of the peripheral drivers, interrupt management, power management, a lot of basic middlewares and communication stacks such as USB, TCP/IP, graphics libraries, and the like. Also some RTOS support there in terms of free RTOS. And all of this lower layer stuff, production ready, optimized for architectures by Atmel development experts, allowing the customer to really focus on the differentiation of their own application And so just the application differentiation and ensuring that the customer keeps working at the application layer. So what is the message now with this new product? What do we want you to do? We'll continue to promote Mega AVR and X-Mega, but if specific Cortex-M0 or M0 Plus is required not to lose a design, then please contact Atmel Sales for approval to promote SAM D20 to the customer. So please work with your local Atmel FAE as you promote this product into the marketplace. But after the public launch, you'll be able to sell SAM D20 where you sell X-Mega D today, and SAM D20 where you sell SAM N today, where Cortex-M3 or M4 is overkill for the application. But if a customer is happy with AVR, it has been a market standard for a long time, and continue to promote it. We're quite happy for customers to keep using those products, and we'll continue to manufacture AVR for at least the next 12 years. Thank you. So in summary, SAM D20 combines the best of Atmel AVR MCUs with the Cortex-M0 Plus. Peripheral intelligence, offloading the CPU, sleepwalking, the ability of some of the peripherals to work independently, event system, offloading the CPU, the best real-time performance in the form of the asynchronous event system, and latency-free peripheral signaling. The SERCOM module offering a huge amount of flexibility in the interface, flexibility in PCB routing by being able to choose which SERCOM module you configure as which interface, SPI, I2C or UART, and also having multiplexing in the IOs, so you have even greater flexibility there. And then finally, short design time facilitated by the development tools, the Atmel software framework, and also reasonably easy migration between different parts. Thank you. That concludes the introductory presentation.